Saxon Algebra 1, lesson 119. This is a connected lesson to 118. Remember, yesterday I told you that we have 3 ways to solve what we call quadratic equations. And that's where we have something that looks like ax squared plus bx plus c equals 0. We call that the standard form of the equation. The first way is by inspection. That's what we've been doing for a long time this year. We look at it, we find the two numbers that multiply to that and add to the b value, and then we just write the parentheses and go. Yesterday we learned a very long and dramatic process called completing the square. That's a way to solve, by completing the square. That will work for anything. This only works when the numbers are easy. This works for all, and the one that we're learning today also works for all. Here's what happened. Mathematicians developed this completing the square methodology for solving any kind of quadratic equation, no matter what the numbers were. But several of them sat around by themselves going, that's really a pain in the bootay. I don't like completing the square. It's too long, it's too complicated, there's too many steps, and I don't want to use it. What I wish I had was a simple formula that I could memorize or write in the front of my math book, because I'm pretty sure that those 1600, 1700 mathematician philosopher dudes all had spiral notebooks, and I'm sure they wrote their formulas in the covers. They said, if only we just had a simple formula. And then they said, by gosh, let's work it out. Several of them, I think, came upon this more or less at the same time. I don't remember their names and who did what, but you could always look it up if you want to know. And this is what we call the quadratic formula. Okay? And I'm going to show you how that quadratic formula came to be. First of all, I'm going to tell you what it is. X equals I'll give you a second to write it down. Maybe you've seen it before. I know of, well, let's see, Jackson, you know this family. You know the Days because your sister is friends with Charlotte, who is the youngest member of the Days. We've known the Days since the beginning of time. Well, literally before Charlotte was born. Nick, the oldest brother, is the same age as my youngest daughter. So we had connection there. And I taught math to Nick. And he told me that when he was a little kid, his family had some sort of like little kid song tape. And there was a song of this formula that he memorized when he was just a little kid. So he was well chuffed when I introduced this formula, because he's like, dude, there's a song about this formula. So I don't know if you ever cross paths with Nick, but ask him to sing you the song. Okay, X equals minus b plus or minus the square root of b squared minus 4ac. And then when you memorize it, I want you to always say it this way in your head. All over 2a. Some people accidentally, some students, it's very common to forget that the line, and they just put the 2a underneath the square root part. No, the whole thing is over 2a. What we are going to do eventually, I will explain to you, if we can identify the a and the b and the c values of an equation, which is super easy, we just put it in order, then we can plug them into this formula where the a's, b's, and c's are and simplify. And then we don't have to complete the square. Now, it's a really confusing looking formula, and students often go, how did anyone ever come up with this? Well, I can show you. What we're going to do now is develop the quadratic formula using the completing the square technology. And by the way, these work for all. That's why I put those by them. Inspection only works for certain quadratic equations, but both of these methods will work for all. Okay, so what we're going to do is we're going to start with our standard form. ax squared plus bx plus c equals 0. Now, the first thing we have to do when we're completing the square is we have to get rid of the a term. So what we're going to do is simply divide every single term by a. We haven't really run into that in our homework yet, but I'm telling you that's how you get rid of the a. And we don't want an a, we want just the plain x in front. Okay, so now it's canceled there. We've got ugly fractions. Let me just fix this. It would be x squared plus ba times x plus c over a equals, and then that would just be 0 because that a cancels too. Okay, and that's okay. We don't mind that. Now we need to kick this guy to the curb. So we'll do x squared plus b over a x equals minus c over a, right? Okay, that's cool. Now we've got a gap here. Oh yeah, magic number. Our magic number is b over a. And remember how I told you it can either be, the magic number calculation can either be divided by 2 or times 1/2. I think it's right back here. I told you yesterday. Magic number. There it is. You can either take b and divide it by 2, or remember I said when we run into fractions, it's fine if you multiply it by 1/2. So that's what we're going to do. We're going to multiply it by 1/2. Then we're going to square it. This number is what we're going to need later, right? When we write our perfect square. But when we're actually squaring this, we need to do this calculation. So it will be b over 4. It'll be b over 2a squared. So that will be b squared over 4, because that's the 2 squared, and then a squared. And that's plus. Oh, okay. And then we have to add it over here as well. That's kind of crazy, right? But we're fine. We're fine so far. Now we need to write this as a perfect square. So it's going to be, I'm going to write it the long way first, and that will be, this number will go on the inside of it, and it'll be plus, it'll be b over 2a, b over 2a. Now remember, I can check this and make sure it's right. If I multiply it, I'll get b squared over 4a squared, yes. If I add it, I'll get 2b over 2a, and then the 2's cancel, so it'll be b over a. Okay, check. Then I'm going to rewrite it as x plus b over 2a squared, right? I can collapse that down to that. All right, now I'm going to combine these, but I have to make the denominators match. That's an a, that's a 4a squared. Okay, so I better multiply this side by 4a and that by 4a, right? So then I'll have minus 4ac plus b squared, and it'll all be over 4a squared. Okay. And I wrote it up here, but there's nothing more to do to it. Remember last time we would do that and then we would actually do the math. But what I want to do is I'm just going to rearrange the pieces. I'm going to bring this out here. So I'm going to say this is equal to b squared minus 4ac over 4a squared. If you go back and remember the quadratic formula looks like, you'll be getting excited because this is starting to take shape, isn't it? It's getting quite exciting. Okay, now we take the square root of both sides. Okay, just like always, we see that the bottom is a perfect square. We'll be able to clean that up. This side is going to be x plus b over 2a, right? Those two cancel out. Equals, okay, the top, it's going to be plus or minus. We have to remember that. The top, I can't fix. That's just drama. B squared minus 4ac. The bottom, I can take the square root of. The square root of 4 is 2. The square root of a squared is a. Are you ready? The last step is to subtract this to isolate the x. I'm going to write it over here a little bit because I have to simplify one more time. I knew I would want to do this on the other page. Let me write it over here. I don't want to be that crowded. X plus b over a equals, I'm just copying. Okay, I wrote that wrong. That's supposed to be a 2a. Okay, x plus b over 2a, x plus b over 2a equals plus or minus all of that. I forgot the plus or minus. Okay, this is out of the pig house. That's still in the pig house. Okay, double check to make sure I'm on camera. There we go. All right, our last step is we're going to subtract that minus b over 2a plus or minus the square root of and remember last time how I said we don't combine them, we like to leave them separate? Well, in the case of this formula, I lied. We're going to combine them because look what happens when we do. X equals minus b plus or minus that is the formula. We derived it by taking, right? Remember we started with this, ax squared plus bx plus c equals 0. That's the standard form of a quadratic equation. And we just pretended that the letters were numbers and we completed the square. And this is what we got. And this is what we call the quadratic formula. I believe that in the homework, John asks you to go through this process that I just went through, to take the standard form of a quadratic equation and use it to develop the quadratic formula. I just did it. So you can copy that the first time or two that you do it in your homework. It's kind of hard, I agree, but it's super fun. All right, so now how do we use this monkey to actually solve problems? All right, I have one hint for you, and it's not a hint. Use buckets. And here's my favorite story about using buckets for this. And by buckets, you know I mean parentheses. Where each letter is, we want to fill in. I don't know if you guys remember Isabel Smith. Remember the Smith sisters? If you went to Eastgate, Everett, or Westgate, sorry, Westgate. If you went to Westgate ever at all, I'm sure you know the Smith families. 3 girls, Mackenzie, Isabel, and Natalie. How old is Natalie now? I don't know. They're all older than you guys, but their family was super prominent at Westgate. Their dad was on staff. Their mom led like the children's choir and stuff like that. They were involved in a lot. And Isabel, the middle daughter, has many gifts, but math wasn't her strongest suit. You know what I mean? She's a wonderful person who has many gifts, but math was an uphill battle for her. And she often felt like she was struggling to keep up. Well, one of the things she did to try to help herself was she not only took classes with me, but she also took algebra classes with Nancy Chang at Edmonds Heights. That was a really bold thing to do. But sometimes it was really helpful because she would get taught the same thing multiple times, and that kind of helped her. So that's why she liked to do it. Well, she learned the quadratic formula from me first, and she heard me rant and rave about using buckets. And you'll see in a minute how we do it, but we have to use buckets to pour the numbers into, because when you have negative signs in a formula and you get negative signs in your values, which we'll see the A, B, and C values often include negatives, it's a recipe for disaster unless you use buckets. And I made this point and I ranted and raved to her, and she went into class a week or two later, and Nancy was teaching the quadratic formula. And so they were working problems together in class, and It was the kind of thing where Nancy was working it on the board and then the students were working on their own papers, and they could sort of go ahead if they wanted to, or they could go step by step with Nancy. And Isabel was feeling good because she'd already learned these with me. And so she was kind of whizzing along on her paper and half listening to Nancy. And then at some point she realized that Nancy had gotten stuck. Nancy had the wrong answer and she was trying to figure out what she had done wrong. And she shared what the right answer was. And Isabel looked at her work, which she had done separately, using buckets, and she had the right answer. And she realized, comparing her paper to Nancy's paper, she realized that Nancy had not used buckets and she had messed up her minus signs accordingly. And Isabel Smith got to raise her hand in class and say, Nancy, I think I know what you did wrong. You dropped the minus sign, blah, blah, blah. I don't remember the details of it. But Isabel pointed out to her what her mistake was. And Nancy looked at her and said, Isabel, you're right. How did you catch that mistake? How did you know? And she said, whenever you use the quadratic formula, you need to use buckets. Oh yeah, it was her money moment. The whole class got to hear Isabel school Nancy Chang, who is a lovely person and is a dear friend of mine. But the students schooled the teacher and told her why she got the problem wrong. And it was Isabel's moment of glory. And I love to share it every time I teach this lesson. So thank you for listening. All right, use the quadratic formula to determine the roots of the equation. Here we go. 3x squared plus 2x minus 7 equals 0. Okay, John gave us that. And after yesterday's complete inability to get everything lined up in the proper form, today he managed to do it. So good job, John. Okay, so here's what we do. It's super easy. First thing we do is identify what are our values for A, B, and C. Well, that's A, that's B, and that's C. The sign matters, all right? So we need to keep track of positives and negatives. A is 3, B is 2, C is negative 7. Okay, that's step 1. Step 2, we write the formula using buckets for each letter. So x equals, x we can write, minus b plus or minus the square root of b squared minus 4ac. And I always say it to myself like that. And when I get to a letter, I write the buckets, but I say it out loud to myself because that helps me remember it. All over 2a. Beautiful. Now we're ready to plug in. Some people like to go in order this way and I'm comparing it up here, right? You always want to make sure you have the formula written out on the same page. You don't have to write it for every single problem, but you need to make sure that it's visually in reach. I like to go in order, so I'm going to put B here. 2 and 2. Then I need A is 3, and I need C, see I'm just following along, is minus 7. And then down here it's 2 times A, so that'll be 3 again. Okay? Now, before I rewrite it, I like to clean up what's in here. So 2 squared is going to be 4, and then these two minuses are going to make it a plus. Let's see, 4 times 3 is 12, and 12 times 7 is what? 84, right? So it's 84. So this is going to equal 88. So what's inside the pig house is going to be 88. So now I'm going to write it over again. X equals minus 2 plus or minus the square root of 88 all over 6. Okay, so I simplify what's inside the radical before I recopy because I don't want to write it 100 times. P.S. That's just a great way to introduce mistakes, right? Okay. Now, I want to check and see what we might be able to pull out of the pig house. And I get excited right away because 88 is 8 times 11. 11 is prime, but this, I know, I don't have to write it out in separate steps. I know that's 2 cubed. So it's all of those. So I know I can pull one pair of pigs out. I'll have a 2 on the outside, and I'll be left with 22 on the inside, right? 11 times 2. So now I'm going to write it one more time. x equals minus 2 plus or minus 2 times the square root of 22 over 6. Makes sense? I just simplified the radical. Now, I'm just interested in canceling. We've done all the hard work of simplifying this formula. I just want to see about this canceling, because I think that what I can do is factor a 2 out on the top and then cancel the 2 against the 6. So let's go this way and let's pull the 2 out of the top. So that's going to leave me with minus 1 plus or minus square root of the 22, right? So I factor out this and this. I'm left with a minus 1 plus or minus just that. This is all over 3. I'm sorry, I got ahead of myself. 6. I was really excited, wasn't I? Now I can cancel that. There's the 3 that I tried to give you earlier. And our final answer is x equals this, minus 1 plus or minus the square root of 22 over 3. That is our answer. Remember that it represents two different numbers because it can be minus 1 plus the square root of 22 over 3, and it can be minus 1 minus the square root of 22 over 3. So this is two values for x. And remember, that's kind of the standard rule of thumb. If we get as many solutions as we have degrees in the highest term. So we have an x squared term, we know we're going to have 2 answers, and this represents 2 answers. And it's okay to leave this squished together as 1, even though I said yesterday I don't like to. In these, it's okay. Let's do another one. Ready? Are you excited? It's fun, right? I hope you feel super duper smart. Use the quadratic formula to determine the roots of. Okay, saying determine the roots means solve for x. It's the same thing. It means find the answer. John got crazy again. All right. So he can't get his equation straight here. So we're going to want to clean this up. We could move the 6 over to this side, but that would be problematic because I don't want the minus in front of the x squared. So even though it takes more steps, I vote we move both of these terms to the left, and then this will be positive, which makes our lives easier. X squared minus x plus 6 equals 0. All right, we can do that. Wait a minute, it's minus 6, not plus 6, because it didn't move. This one changes, that one stays the same. Okay, so now let's do our ABC. A is equal to 1, B is equal to minus 1, C is equal to minus 6. Now I can't see my formula anymore, so I'm going to have to write it again. Make sure you write this down in your book. Make sure you memorize it. I guarantee you there will be a problem like this on the final exam. I promise you. I promise. So you need to memorize this. And then we write it again with the buckets for letters. I got a little carried away with this line, didn't I? Doesn't need to be there. Okay, now we plug in. My B is minus 1, and it's minus 1. And then we need the A, and then we need the C, and then we need the A down there as well. All right, before I start recopying, I clean this up. Minus 1 quantity squared is 1. There's 2 minus signs, so that's a plus. And then that's 24. That equals 25. Ooh, I like what I see. Okay, now we're ready to rewrite it. X equals 1 plus or minus square root of 25 over 2 times 1 is 2. Oh, this can be simplified. I'll go this way so I use up my paper better. X equals 1 plus or minus 5 over 2. That looks pretty good. And now, because these are all integers, we can actually solve this. We don't have to leave it like we did last time in that kind of funky format. We can actually say, okay, what if, let's say that x equals 1 plus 5 over 2, and let's say x equals 1 minus 5 over 2. We can actually solve these because there's no radicals in here that make our life miserable. 1 plus 5 over 2 is 6 over 2, and that means x is equal to 3. And 1 minus 5 is minus 4 over 2, so that says x is equal to minus 2. Wait a minute. These turned out to be a pair of darling cute numbers, and I go back up to the top and I look at it and go, well, yeah, we could have solved this by inspection, couldn't we? Because what two numbers multiply to minus 6 and add to minus 1? We would do this, right? Let's see, it would be x minus 3 and x plus 2, right? They multiply to minus 6, they add to minus 1. Okay, good. Now we look at this and we compare it to our answer and go, oh wait, but the signs are wrong. That's because we're not done yet, right? If we go one more step and remember, okay, these two things multiply together and get 0, that means either this is 0 or that is 0. X minus 3 equals 0, or x plus 2 equals 0. And then we algebra it. X equals 3, x equals minus 2. We get the very same answer. Oh, my book just fell on the floor. We get the very same answer as we did. This is by quadratic formula, and this is by inspection. It works. It always works when you use the quadratic formula. If you get a problem and you don't catch that you could solve it by inspection, it's fine. Just go ahead and solve it by the quadratic formula. Yeah, it's a little more drama, but it's fine. It won't give you the wrong answer is what I'm saying. You'll come out just fine. Okay, so that's number 2. I have one more. Lesson. Oh, what am I doing? I was thinking about the next lesson. Example 119.3. Ready? Use the quadratic formula to find the values of x that satisfy the equation. That's another way John can ask you. So he's asked us 3 different ways. He said, determine the roots. Oh, I guess he said determine the roots twice. And then on this one, he said, find the values of x that satisfy the equation. So don't let his wicked tricks fool you. Okay, let's see if he learned how to write things in order. No, he did not. Minus x equals 7 minus x squared. Just for fun, this time let's push all the numbers this way and just use the minus sign there. It will still come out just fine. I just want you to see that it doesn't matter if the a has a negative or not. It'll still be fine. So let's add the x, and so we'll have 0 equals minus x squared plus x plus 7. So our a, b, and c values will be minus 1, 1, and 7. Okay. I have to write it again because I can't see it. You write it too. Okay, now I write it with buckets. Okay, this time we'll go in order, just to give you a different experience. This time we'll first plug in the A's. Let's see, there's an A here and an A here. The B is a 1. And the C is a 7. There's only one 7 right there. Okay, ready? Let's simplify what's in the pig house. 1 plus, that would be 28, right? And so that's 29. So now we're ready to rewrite x equals minus 1 plus or minus the square root of 29 over minus 2. Okay, can we break this down? No, 29 is prime, so there's nothing we can do to break that down. There's nothing we can factor out. Like in the first one, remember how we factored the 2 out and then canceled it against the 6 in the bottom? Can't do anything like that. The only thing we can do is these two minus signs will cancel. So we can write x equals 1 plus or minus square root of 29 over 2, right? Those two guys cancel each other. And that's our final answer. Yay. You guys, you are now at the heart of algebra. Learning the quadratic formula is so... It's such a leveling up, you guys. You have leveled up hard in lesson 18 and 19. I'm extremely proud of you. If you are even surviving this without completely having your brain explode off your shoulders, then you're doing great. So again, like I said, we're going to spend lots of time with these monsters next year. And this is just a foretaste of the feast to come. Whoa, mark my words. Okay, that's the end of lesson 119. Thank you, goodbye.